How do we synthesize novel views of a scene from only a single 2D input image? We propose a novel method, Worldsheet, for this task. From a single image, we wrap the scene geometry and appearance with a mesh deformed from a planar sheet and render it in novel views. Given an input image and the mesh sheet as a lattice grid, we deform the mesh sheet by predicting the spatial offset and the corresponding depths for each vertex of the sheet. This is done using a convolutional neural network. We then aggregate the intermediate depths and offset to compute a deformed 3D mesh for the input scene. Based on the constructed scene mesh, we propose a differentiable texture sampler to sample its texture map directly from the input image. Given the texturized mesh in the new camera angle, we then render the image from that view using differentiable mesh rendering. The whole pipeline is end-to-end trainable by only taking the representation error from the target view. This fusion of geometry and learning thus allows us to train from only 2D image losses without any explicit 3D or depth supervision. At the beginning of training, the mesh does not feed the scene well. Here, the mesh is just a planar surface without any deformation at initialization. But as the estimates of depths and offsets become better, the mesh gradually gets shrink-wrapped onto the scene accurately. Let's see how the novel view looks in comparison with other single-view-based methods. Im-to-Im, an early approach based on appearance flow, quickly fails as the camera moves into the scene. Compared to Scene-Scene, a recent point cloud-based approach, our model generalizes better to large viewpoint changes and has fewer artifacts. We evaluate and compare with previous approaches on 3 benchmark datasets: Matterport, Replica, and Real Estate 10K. Under PSNR and other metrics, our model outperforms previous work by a large margin on all 3 datasets. Beyond these datasets, we can also wrap our mesh sheet to high-resolution 2D photos in the wild and look at them from new viewpoints. For this in the wild results, we pre-train depths using existing datasets to avoid domain shift. In this train example, we synthesize long-range novel views by moving the camera deeply into the scene. Our mesh sheet can also be wrapped onto indoor scenes such as this bedroom and objects such as the cake shown here. We can even do a 360-degree turnaround in this alley. Here the image is a bit blurry, which we hope to improve with scans in future work. Beyond photographs, our model is even applicable to non-photorealistic paintings, lifting and animating them into 3D artwork. Sometimes artifacts occurs when the depth is discontinuous around object boundary. For instance, in this scene, the boundary of the flower is slightly blurry. Let's see another example. Here the model has difficulty generating regions around the tree because of large depth discontinuity. We hope to address these issues in future work by segmenting the worldsheet around depth boundaries. Thanks for watching. Please visit our project page for more details.